Hi, I'm Lynn Langett. Welcome to Hadoop on Azure. Over the next hour, I'm going to be talking about the Hadoop on Azure implementation that Microsoft has currently and showing you a bunch of demos. So I'm glad that you can join me. This is being recorded for DevelopMentor, and it will be published on the DevelopMentor site as well as on YouTube. So let's get started. So Hadoop has been the buzzword for big data for the past 18 to 24 months, and it's important to understand the use cases for working with big data before we dive specifically into Hadoop and Microsoft's implementation. So it really does come down to the volume of data and the usage of data and the types of data, those three different factors. And you can see in the slide here, I have represented big data as transactions, interactions, and observations, with the scale on the left side in terms of volume, starting with ERP, CRM, web, going into big data, and on the bottom side in terms of data variety and complexity. And this is from the Hadoop vendor, Hortonworks, as you can see. So one of the situations I'm finding when I work with clients, because Hadoop is such a buzzword, clients are asking me when to use Hadoop, how and why to use Hadoop, and it's a very important consideration because it's certainly not the data storage choice for all of the use cases these days. Okay, so is Hadoop itself the be-all and end-all of big data? No, it actually isn't. Although it's what you hear most about, there are many other changes and considerations in the world of big data, and they come under the broader umbrella of NoSQL, which some people think means not relational or not SQL or not SQL Server if you're coming from a Microsoft world. But what it really means is non-relational data storage mechanisms and query mechanisms. Now in this webcast, we're going to focus specifically on Hadoop and its implementation on Windows Azure, but I'm assuming that you, like me, when I came to this, and many of my listeners will be new to Hadoop. So Hadoop actually comes out of technology invented by Google to process, store, and use the index information they created around the web. And I've included some links here on the slide to the open source implementation of the technology inspired by Google. So it's under Apache Hadoop, and as it says, it's a software framework that supports data-intensive distributed applications. Distributed would be the key, massively distributed, has a free license, and you can work with thousands and thousands of nodes and petabytes of data, huge amounts of data. It was inspired by Google's Mapreduce technology and the Google file system. So it is helpful when you are getting started with any implementation of Hadoop, whether Microsoft's or Amazon's or even Google's public implementations, that you understand a bit about the underlying technologies. And these are the most useful links. So the reason that I came to be interested in Hadoop about a year or so ago was because of what the traditional RDBMS vendors were doing around Hadoop. At SQL Pass last year, I was there when Microsoft announced its connector from SQL Server to Hadoop, and the week later I noticed that Oracle announced a connector or a loader for Hadoop. And this really got my attention because I hadn't really done anything other than cursory exploration of Hadoop technologies until these announcements last year. I felt that this was really the tipping point in terms of customers that I would be working with, because if these major enterprise RDBMS vendors were creating connectors, neither of which is known, these vendors, for playing well with open source, there must be a compelling business reason for me to take a look. So I've got links to both of these connectors, and basically they allow data interop between a Hadoop instance and the RDBMSs. Of course, this is not the focus of this screencast. We're going to talk about a Hadoop implementation, but this is what caused me to take a look at Hadoop. As I had said, Hadoop is just part of the flavors of NoSQL database systems. I have an entire presentation that you can see on my YouTube channel. I have the slides for it as well, called NoSQL for the SQL Server DBA. And if you're interested in understanding some of these other implementations of NoSQL, such as graph databases like Node.js, other column databases, document databases such as MongoDB or Cassandra, key value databases that are either persistent or volatile, such as I think Voldemort is one of those. You might want to take a look at that presentation. Also, I have a link to a very good blog post here just to understand the technology. In the world of Hadoop or Mapreduce storage, we are looking at a wide, sparse column set. So you can see this is the inspiration, the Google file system, and Mapreduce is how you work with the data at the most raw level. There are also some other implementations and technologies. Big table listed there, something called Sawzall, which I know more as Pig or Hive. But underneath this green drawing is a representation of this variable size column store. That is how Hadoop represents data. Again, just to give us a kind of an overview, this is my simplification of a chart I got from Tom White's Hadoop, the definitive guide. And you can see the traditional RDBMS has an upper limit of scaling from practical point of gigabytes or terabytes, although there have been larger implementations, but it becomes prohibitively expensive. Hadoop is much more cost efficient at those huge size scales. Note that traditional RDBMS has both interactive query and batch processing, and Hadoop is focused on batch. This is actually extremely important. The Mapreduces are run as batches, and we'll see this, and it's not designed for interactive query through Mapreduce. There are some structures you can impose on top, but because of the massive size and the parallel execution, the batch is really important to understand. Of course, RDBMS are read-write many times. Hadoop is write once, read many times. So in some ways, you can think of it as a type of replacement for our classic data warehousing. Certainly has different functionality in terms of interactivity, but in terms of pure storage, it's got the scale. The structure for RDBMS is static. For Hadoop is dynamic because of the variable with column store. The integrity, in terms of transactional integrity, is high in RDBMS, sometimes called ACID, low in Hadoop, sometimes called base. Scaling is nonlinear in one, linear in the other, and the query response time is affected as shown on the slide. So when we're thinking about a Hadoop implementation, we might want to consider kind of what this cartoon makes reference to. Not only do we want to think about which NoSQL implementation, obviously this talk is focusing on Hadoop, which technology, but where we want to implement this technology. As a point of inclusion, the beta bits that Microsoft has released to those that they're including in their beta program for Hadoop include two implementations. One is a purely web-based that is hosted in their Azure cloud. That's what I'm going to be showing you today. There is another part of this implementation. The internal name is called Isotope, which runs on Windows. You can install it on any machine in your network. So I've actually had access to both, but I'm focusing on the Hadoop on Azure for this particular talk. That would be obviously consideration when you're figuring out these technologies. So when I'm talking with my customers these days, you've got two pivots for data solutions. One is your storage method, whether it's traditional or, in this case, Hadoop or some kind of NoSQL. The second is whether it's on-premises or cloud-hosted. Of course, cloud-hosted is an oversimplification. It can be public cloud or more and more. There's some opportunities around private clouds. That goes beyond what I really intended to talk about in this short talk. So with that overview, let's get into it. So this is the screen of what Hadoop on Azure looks like. I've actually set up a cluster already because it takes about 5 to 15 minutes for that to happen. So once your account is approved, your Windows Live ID, once you apply for the beta, and I believe it's an invite-only beta still at this time, although I think the team expanded it a bit, then you log into the Hadoop on Azure site, and the very first thing is you request a cluster. Now I noticed a change. I went through this last night. I've been working on this for a couple months. It looks like as they've broadened, the team's broadened the beta, they've made the size of the cluster fixed now in the beta period. Before you had 4 different sizes, as you can see across the screen. So from 2 terabytes to 16 terabytes, just a small Hadoop cluster. Then you put your login, and then you can optionally store, use the SQL Azure instance for the Hive metastore. Now what Hive is it's a query mechanism that can be used once you create a Hive table out of some Hadoop data. And it's HQL, so it's T-SQL-like. It's a little bit misleading, though, because it's not T-SQL. You don't have joins. You don't have all the things you have in your DBMS. You have a simplified query language that you can use. So you notice that's optional. So let's go now to my instance, and I'm going to go ahead and sign in, and then I'll show you what this looks like. So I've got my sign in here, and let me just put in my password, and then I'll show you what the cluster looks like. So Microsoft used the Metro style buttons here as they're branding everything these days, and they have a little snazzy saying that changes here. So you have a couple different sections in the web-based administrative client. You have a section with purple buttons around tasks or query jobs, which are called the Mapreduce jobs generally, where you can see which jobs have been run, what is the status of the jobs at a glance, and then if you click on it, you can see more. The next section is a green section where you manage your cluster, and the bottom section is yellow where you manage your account. So let's just go through a couple things here. So first of all, if you do get access, happy to report that it's absolutely zero cost, which is a really refreshing and great thing to see from Microsoft around Azure. So they've done a great job with that. So zero cost during the beta period. Now that's good and bad. Good because you can try it out. Bad because we have no idea what the cost will be. Now there are other vendors that have production cloud Hadoop instances out there. Amazon is the most notable. They have Mapreduce. So in terms of comparing costs once it comes out, that would be a place to look. The next area down here is downloads. And what this has is I would highly recommend if you get access that you go to the how-to and the FAQ. Many of the examples that I'm going to show you are straight out of there, and they do help you get up and going. The second thing that you're going to want is the Hive Odbc driver, and this is so that you can connect with Excel, which we'll be talking about a little bit later. The next thing is you have a complete job history. Now, one of the things during the beta is they haven't been cleaning out the clusters. So what happens is you have a certain period of time, you can see right there, and then you can either release or renew it. If you release it and then you sign on with the same information again, you notice my cluster is called linlanget.cloudapp.net, and if you had previous jobs, like I didn't do 59 jobs this morning, they'll just still stay in the job history associated to that name. I'm sure when they go production, they'll clean that out. So down here, you have a bunch of samples, which we'll be taking a look at. And these are really, really helpful, again, when you are getting started. One of the reasons I got interested in this technology is Microsoft's done a really good job with on-ramping. I went sort of the traditional route with Hadoop, looking at some of the other vendors' implementations, Cloudera, Hortonworks, and maybe it's because I have so much history around Microsoft, I found the Microsoft on-ramping to be really easy. And that's important. That's important when you're learning a new technology. So the second part of this is you have managing your cluster. So the first thing that you do is once you set it up, you're going to want to get some connectivity to it so you can get data into your cluster. So there's a couple different ways to do that. The first thing is on this managed cluster, you have a visual indicator how much space you have left. You have a disaster recovery, which shows you how often this thing is snapshotted. If you click on that, so you can see right now it's configured automatically. And then you have some different places you can connect to pull data from. Now you can directly upload data, which I'll show you as well in a minute, but you can pull from Windows, Azure, Blob storage accounts. And to do that, and I'm just using the new DESIC Azure Storage Explorer because I like it better than what you get in the portal. Basically, if you have a container here, and here's your, in my case, my Azure storage account, and then here's some different text files that I'm going to work with, then I can just work with them in my Hadoop cluster. I can do my processing. So you connect directly in, and the way that you connect is and I have this in the slides. I don't want to show it here because I have my key already. You just put in your endpoint name and your private key, and then you can access this as if it were local and pull it in. Same thing with Amazon S3, so I'll show you what that looks like. which is a nice addition. So here's my S3, and you can see here I've got a long text file in my S3 bucket, and I'm going to be working with that in an example coming up. And then here's Windows Azure Data Market. So I left this one blank so you can see what it looks like. You put in a username, a passkey, in this case a query, and then if you want to create a Hive table out of that, you put the name of the Hive table. Now if you're not familiar with the Windows Azure Data Market, the way that it looks is, let's see, like this. And what this is a public data market where this is hosted by Microsoft on the Azure infrastructure, where you can get access to different data sets. So for example, this is lawyers.com, consumer legal articles, and you can see some of these things have a free access tier, and some of these data sets you have to pay for. So here's one where you have a free tier, but you have to pay its public addresses if you want to use it for like data cleaning or validating data. So this is becoming more and more a trend around big data, that it's not only your data, but it's some sort of public data access point. This isn't the only marketplace. There are some that are completely free, like Freebase, that's by Google. InfoChimps is, I think, it has a mixed model there too. The way that you would work with this is you would go into your particular data set, and then down at the bottom, explore the data set. You can look at it in Power Pivot. You can look at the REST interface through Visual Studio. They have a pairing with Tableau, which is a third-party vendor. So when you explore the data set, you're building the query here, and here's where you'd see your private account key. And let's see if this will even bring up anything if I run a query. So this brings me a query, and then here's the URL for the expressed query. So that's what I would paste in to retrieve this particular data set out into my Hadoop cluster. So that just kind of shows you how the interaction goes. The query is a URL against a validated endpoint. So these are the areas that are supported initially, and I don't know if Microsoft will add some other endpoints or more open configurable endpoints rather than specified locations, but this is what we have right now. So once you configure where you want to pull the data from, if it's one of these locations, then the next thing that you're going to probably want to do is get that data up into your cluster. So to do that, you may or may not want to open either the FTP port and the Odbc server port. Now this is for Excel connectivity more than anything, but you can directly FTP as well. So these are closed by default. Then the next thing is you have a couple ways to work with your cluster. You can work with it through the Interactive Console, which we'll come back to in a minute here, but you can also just directly RDP into it. So to RDP into it, you just say you open the port, and then you go to the remote desktop, and it'll download you a shortcut file. And then you just say OK, and then OK, and it's going to allow you to RDP in. And now you're RDPing in, and you can see that you have, this is really good if you're coming to the table with Hadoop experience, like from another vendor, or just you've worked with it in another format, because this allows you command line access, which some people who work with Hadoop are already familiar with, more comfortable with. It's just faster for them. So you've got working with the configuration itself, what's called the name node, which is the sort of the head node, and then you have the secondary nodes. So you can just work right in the command line here if you want to. This is the Hadoop command shell. You also have a couple utilities in here. You have the name node utility. This is a very simple website, which just shows you what the configuration of your Hadoop cluster is through this name node machine. So let's get out of here, and you can see here, and here's the configuration. You can see that, the percentage of space used, so all this good admin stuff, basically. You can see that this implementation is ported to Microsoft, but it is a Hadoop 20.203.1 snapshot, so it's standards compliant. You can see if any of your nodes are dying out. You can browse the file system. And it's taking a second, and there you can see the HDFS area, basically. So you can see the Hive, if you have any Hive tables. So for those who are familiar with Hadoop technologies, this can be a faster way to work with things. So you've got that one, and you've also then got the Mapreduce. And Mapreduce is a key element when you are working with Hadoop because you have distributed processing of your data, massively parallel, so you want to monitor the status of your batch jobs. So you can see if you had jobs running, you would see the map tasks, the reduce tasks, and you can look at if everything's working, anything is down, what's running, what's complete, so on and so forth. You can see some complete jobs. I just ran a job before this, so you can drill in and you can see the percentage of completion. You can see detailed information about the overhead of running the job, so on and so forth. You can also directly, of course, work with the file system. Again, something people have been interested in is, let me just show you, sorry. Let me just show you in here, and I go computer, and I'll show you the specs for the computer. So this is Hadoop. This is the isotope port, if you will, running on Windows Server 2008 R2 Enterprise SP1. We have a quad-core processor on the head node here. So you can see it's 14 gigs of RAM, 64-bit. So just to kind of show you what this looks like. For this, for this webcast, we won't spend much more time on the RDP section. Some of the samples do require that you RDP in rather than work with the Interactive Console. So let's pop back over to the slides here. So we set up our cluster. And when you're setting up your cluster, you get the allocation process showing there's isotope, the head nodes and the worker nodes, the allocation process. Again, it takes between 5 and 15 minutes, so I preset it up. And then this shows Microsoft's implementation of Hadoop on Azure. I know it's got a lot of technologies there, but it's a translation. This is really more for if you're coming to Microsoft's implementation from knowledge of Hadoop. If you're new to Hadoop, this is probably a bit overwhelming. So you can see you have the data sets, you have isotope or Microsoft's implementation, you have some presentation layer, which interestingly does include Excel and Power Pivot, which is again, another reason I took a look at this, because it is interesting to push the Hadoop data all the way down to the subject matter experts in these self-service BI tools. The isotope components themselves, you've got the data integration, which is Flume and Scoop for SQL Server for interop. You have the storage layer, HDFS, the compute layer, which is Mapreduce, which we're going into next, and the advanced query. Now you have stuff that even sits on top of that, like data mining. Won't have time to really get into that. If you're very much wanting to explore all the possibilities, I do recommend you look at this. I have, and it's kind of cool. But you want to start with the Mapreduce and the advanced query layers. One of the things that I've found in talking to my audiences who seem to be mostly having an RDBMS background like I do is it's somewhat helpful. I actually made this. I took the most common DBA tasks from a presentation at SQL Pass last year, so I credit the author in the slide notes here, and I listed those down on the left. On the right, I translated them to the DBA tasks for Hadoop on Azure, which for those of us who are more on the DBA side rather than the database developer side, I think is kind of useful. So for example, you still have to import the data into Hadoop, but you're going to have to figure out how you're going to get the data there, which is a bigger concern, especially on the initial load, because you can have massive amounts of data. There are other ways than FTP or Scoop, but I just put a couple of them down. Security is always a concern. Scaling is trivial in Hadoop, adding child nodes to the cluster through the command line, or there's other methods. Replacing failed nodes is how you have a business continuity. Cleaning up data via ETL is done in many ways, but one of which is executing something called a pig job, which we may take a look at here depending on time. Creating an index or query tuning isn't really a consideration. Rather, it is simplified direct querying through Hive. Joining tables together is done through the earlier processing through Mapreducing. A big part of your admin tasks on the Hadoop side is monitoring these could be massive Mapreduce jobs. You can use cron jobs to schedule them. You're going to always be monitoring, again, as opposed to running database maintenance, and you probably will be interested in resource threshold alerts. And a very big difference, this is assuming that you're in the cloud with Hadoop, Hadoop on Azure, as it says, is managing usage time charges and compute time charges versus licensing costs. It's really coming up very frequently with databases of any type in the cloud. So we took a look at basic administration. We opened up the ports. We connected via RDP, and we looked at the included utilities, the command line shell, the command shell, and the web utilities for people who are more familiar. And this is, again, just screenshots of them. So the name node utility, the top level, the name node, the drill down level. We then looked at managing cluster, so providing security information so that you could pull data via other cloud locations, in addition to FTPing data to your Hadoop cluster to work with. So this is what the upload from Amazon looks like. You have to have the access key and the secret key. I actually wrote a blog post about this on lynnlanget.com, so you can just search on my blog if you want to try this example. I also have some more information on an article that I recently published in MSDN magazine. So one tip, though, I found when I was working with this, and this was a while ago, although I reran it this morning and it worked okay, was to use the S3 native file system protocol rather than on the block file system. The first time, and this, to be fair, it was over a month ago, when I first set it up, I couldn't get the S3 to work. So just a tip, and maybe it works now, but that was what I found. Configuring the upload from Azure, you need the storage account name and the passkey, and then you can work with Azure Storage if that's your interest. And then my tip is to use the free Azure Storage Viewer rather than the default portal. I think it's just more useful, and it's free, and it's from Nudesic, which is a vendor from Microsoft. I talked a bit about configuring upload from the Windows Azure Data Market, and I showed the interface for that, where you'd have the username, the passkey. I showed how to create the query by finding the data set of interest and then using the interactive browser on Windows Azure Marketplace to create the query. And then I mentioned that you may want to create a Hive table out of that, so you can do HQL queries against the result. So speaking of asking questions of this Hadoop data, which in fact, of course, is the point, I'll give you a minute to read this. So this is our dilemma, all of us RDBMS professionals who are experts at T-SQL. We are very comfortable with writing queries that will produce correct results and reducing the overhead on our RDBMS systems in most or many cases with the data volumes that we had in the past. So, why do we have to change? Why do we have to move to this new system? Well, it really comes to volume, sheer volume of data. And the need to do this distributed processing. So Hadoop is designed to be, the data on Hadoop to be worked with via Mapreduce. And Mapreduce, if you are new to it, is best understood through the many samples that come with Hadoop on Azure. Sort of the classic Mapreduce first example, the hello world of Mapreduce, if you will, is word count. So one of the things I really like about the samples that are provided with Hadoop on Azure is there are several examples of word count because there are different ways that you can accomplish a Mapreduce. What a word count is, as it says in the sample here, is it counts the number of occurrences of each word in a given input set. And it says upload the data via FTP, JavaScript, and execute JavaScript, pig, or jar. So we probably should take a look at what some of this means. So I'm going to go ahead and close my window. I have an airplane flying over. So there we go. So if I go to my sample here, and I go to create job in my console, you can see I have a whole bunch of examples, and I have a lot of word counts. So I have truly done all of these. And I click on create job. Now what I can do is if I have a job already written, I can just run a job against data that I have accessible through my Hadoop cluster. And the job by default expects a jar file, which is a Java file. So again, a complexity of working with Hadoop, because it comes out of the open source community, is it's not first set up to be worked with languages that most Microsoft developers are familiar with. I know some C# developers also know Java, but not all. So rather than doing this, What you may rather want to do is to work with the samples. So if you go to the samples, that's not what I wanted to do. Let me let it finish rendering. If you go to the samples, you can see here we've got our various samples that I have the screenshot showing. I'm just checking to see if there's any new ones. So if I click on word count, what I get here is I get a very well-written explanation, and it basically says it's going to read some text, a book basically, and count how often words occur. So we got text files. The output is text files. Okay, so might seem simple, but it's a good way to get started. So you have a couple different ways that you can do this. So you can run this via something called the Javascript Console, which is an interesting implementation that Microsoft added. And again, a reason that I'm taking a look at Hadoop on Azure. In addition to using straight Java to run Mapreduces, as you can tell by this, you can use alternatively JavaScript. So I'll be showing you that in a minute. Here you can use FTP to put your data up. And here you can use a jar. So what that means is you can either use JavaScript to run the Mapreduce, or you can use Java in this case. And it shows you what the syntax is of the various files. And then over on the right side, it gives you downloads. So you can download the Java file or the JS file. So this is an either or. Here's the sample input, DaVinci.txt. Here's a compiled jar of the Java file. So you would need the jar to be available if you were going to use the sample for just creating a new job through the job interface. So if I click Deploy to Cluster, what it then does is it opens that create job and it populates all the values. So it's a really quick way to get started. So let's understand what we're looking at here. It gives us a name, word count example, and then it gives us a jar file. So it is that compiled Java file. Notice I can replace it. This particular jar file expects a couple of parameters. It expects a function, basically word count, and it's taking that in plain text. And it expects a parameter where the data is coming from. So you can see here's the final command. Hadoop jar, Hadoop example, there's the version. Snapshot jar, there's the method that's going to execute word count. And there's where the source data is going to come from, DaVinci.txt. And there's the output, DaVinci all top words. Now a couple things are interesting here. In addition to getting the parameters from just plain text, if I click the drop down, you can see that I have some other locations. I can get it from S3, that's Amazon S3, and in order to do that, you would have to have that configuration set up. If you try to do that, if I click on it here, you can see I have a little triangle, and it would actually validate whether I could get that or not. So if I click over here, this is not valid because it went out to S3 and it tried to find this location. Now, you'd have to put the bucket location of Amazon to do that. Again, I have written this out in my blog, so if you want to try something through Amazon, you can do that. Here is for Windows Azure Blob storage. So this is the protocol for that. And again, this would come up as invalid because I don't have this configured correctly. And here's for the HDFS file system. So you have 4 different options that you can work with. So the interesting thing is not really so much the parameter, rather you can get your example data. So I could here pull my data from S3 or from Windows Azure storage, so the alternative ways, or the HDFS file system. So once I'm done configuring my job, which will have 2 parts, it will map and it will reduce. And as the job is running, we'll get into kind of how that works. I can then execute the job through the portal. And notice it will say running, and then it's going to give me output and the debug output. So there's quite a few mechanisms on the portal for you to monitor the status of any running job, because it's a big part of working with Hadoop, looking at the status of the jobs to make sure they run properly, and then of course looking at the output to see if it's meaningful. And you can see here we've got the job started, and it is mapping and reducing. So while it's running, we're going to go back to the slides, and there it's 100% mapped, and now we're going into the reduce so that we can understand, assuming that you're new to these technologies, what it means to Mapreduce Hadoop information. So there's where we were, and you can see this create job relates to this. And if you look in the slide, you can see that I've actually made the slide with the example going out to Amazon. So you just put the location of the bucket, and then a folder, and then the name of the file, and then the output file. So it's pretty simple once you've set that up. So one of the ways, interestingly, that I found to communicate to .NET developers around what Mapreduce does is to use some of the other samples. So I have samples that I've worked with from the portal that are around JavaScript, Java, and interestingly, there's a sample that Microsoft has written around C#. So this, of course, is truly unique to Microsoft, and again, makes it interesting to those of us who are Microsoft developers, assuming that most of us use C#. So this is a screenshot of what the files look like. Obviously, you can get that Mapreduce is a two-part implementation. So mapping basically takes your file and does some sort of processing on it. In our case, we split the words. So it's just as simple as we read the information in, and then we'll do a split of the words. Reducing, so you can almost think of it like a get a certain subset of information out if you're mapping this back to relational. Reducing is taking the words that you have, and in this case, counting up the same words. So making a count of the words. So this relates directly to aggregation. So a group by with the sum. So, but massively parallel. So let's go back to our running implementation and see how it's going. So you can see that we had a mapping, 100% there, and then reducing. And there we can see all the information about how many records were written, so on and so forth. So the job has completed successfully. And if we go back to the cluster, you can see that it's complete. And if we click in, we go back into that job, and we can see the job history at the bottom. And we can see there's the job history. And if we click on it, this takes us all the way back. So through the portal, we have the ability to work with job history. And now, of course, we have a new job in job history. Oops, clicked the wrong thing. And wait for it to render. Go down here. Hold on, I'm clicking too fast. I'll wait for it to render. Click on the job history. And the job history, this is a complete job history now, so you can see that I have this job history that just ran. You can see I have some failed jobs too, because if everything worked perfectly, we wouldn't have there wouldn't be a need for so many of us, would there? So let's go back to the sample and take a look at the Java. So if we scroll down, we got a bunch of imports, and then here we have the word count. So here we have a mapper, okay, and here we have a map. So we have a string tokenizer, and we're working with splitting out the words, the text into words, basically. I'm trying to find, because Java is verbose, I'm trying to find kind of the salient points. So here's the reducer. Here's the for int writable value sum plus equals value.get, results.set of sum, and write it out. Oh, one important thing when you have a map, you have a key value pair. That's the output. And then there's the main, calls those. I realize if you don't know C#, this is probably not the most helpful thing. So I have another language I'm going to show you in just a minute. And that language would be JavaScript. So another way that you can implement Mapreduces or other processes on the data in your Hadoop cluster is through the Interactive JavaScript Console. Again, really kind of a neat thing that Microsoft did with this implementation. So you get there through the portal, and we'll be going there in just a minute. And we're going to use our same word count example, but this time we're going to use JavaScript, which I find much less verbose and much more friendly, and I tend to want to work with it this way, so I've written quite a bit about it. So you have two possibilities when you work with the JavaScript console. You have JavaScript and you have Hive. It looks like we may not get enough time to go into Hive today, but we'll come back at the end. So let's, I guess, go there. So if I go back and I go to the JavaScript console, I must wait. All right, it wants to render twice. I think it's a Chrome thing. So I go to the JavaScript console. It says, welcome, type help to get inline help. So I think I'll do that. Click in there and type help. Notice on the upper right, if I wanted to use Hive, I just click the button to switch to Hive. And there I get a list of all of the first level things that I can do. Pretty good help. So notice I can do expressions. I can look at global variables. I have simple graphing, which I'll show you. I can get a list of jobs. Here's Pig. So Pig is an ETL kind of processing framework that you get with Hadoop and Isotope. And here's Hive. So you can actually execute Hive from here. And you can run Hadoop jars from here, parse, so on and so forth. So there's some useful stuff here. Another thing that I would tell you is if you do get onto the beta, Microsoft would greatly appreciate if you use the feedback. So you can say, cool, we are in a webcast, and please let more people join the beta. This is a beta by invite only as far as I know. And there we have feedback sent. Okay? So some other commands that you will want is around the pound sign. So if I type pound sign, you're going to get a whole list of commands that will be quite handy. So basically listing, looking at the contents of files, that's a cat command. And again, I know this is all hardcore command line stuff, and either you know it or you don't. If you know it, you're probably comfortable and you like it. And if you don't, you're probably saying, ugh, command line, but that's the way it is. So what are we going to do inside of here? We're going to work with our example, but we're going to work with our word count example through the JavaScript interactive console. So go to our word count, and you can see that if we want to work with JavaScript, we have to go to the console, and we need to get the file there. So we need to use an fs put. And then they give an example there. And then you want to work with JavaScript in terms of that file. So you do a #ls to make sure the file made it up there, the source file. And then you can actually look at the file, the contents from using a cat. And then you can use this pig command, which I'll go into in more detail, to do the actual processing. So what I actually did for the purposes of time is I ran a lot of this because I knew we would run short on time. So here I have a #ls, and what I did is I went against S3N. So that's going to be my my Amazon location. And I have a books directory, and I have the DaVinci.txt directory, which I already put there. And then what I did is I did a #cat. And then what that does is that shows what the contents of DaVinci.txt is the Project Gutenberg ebooks of the Leonardo da Vinci, blah, 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 blah. So it's a long text, if you will. So then, and I actually made a subset of it because it's really long. So blah, 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 blah. So you can look at, and there is a size limit, by the way, of how much you can upload here. All right, so then getting down a little bit lower, there, end of the book. Sorry, just going down a bit more here. There we go. So now, end of the book. So now the next thing, once you got this book up there, then you need to take this Mapreduce file. and I'm going to actually show you what it looks like over here. This is an article I wrote in MSDN Magazine on the same information, basically, so you can see the URL right there. So there's the Mapreduce, and there's the JavaScript. So this is a Mapreduce in JavaScript, much more terse. It's like 15 lines versus over 60 lines in pure Java. So you got a map function, key value context. You have your words split with the regex. Then you have a for loop, and then words.length. If the words is not equal to nothing, then write out the words, lowercase. So split the words is what you're doing right there. And then you want to count them, basically. So reduce is function. The key values is the output of the split. And then you just count them out. So what this does, and this is a file called, I think mapreduce.js or something, the pig processor will allow you to call this. So let me show you what that looks like. So pig.from this location, so take this source file, or take a source file from this location, .mapreduce. So apply a Mapreduce function that is found in this word count.js file. For each word, applying a count of long, then order the results by count descending. Take the top 10 to, and this is the source file, DaVinci to the destination of DaVinci top 10 words.txt, and then run the job. So when you run the job, you can see here you get job a link to job progress inside of here. So you can see here it is, and it's view log. And then again, I ran it because it takes believe it or not, it takes a minute or two to run. So you can see that, let me make this smaller so I can work with it. You can see that, again, you're connecting, and then you're going to be doing, here's your, see, you're mapping and you're reducing. So that's the whole thing. Percentage of time mapping and reducing. And then you scroll down, and you can see the output, blah, 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 lots of stuff. See here, you're 70% mapping and reducing because it's distributed. And then it's showing you, this is what, of course, you want to see, success, that you have created this output file. And notice it tells you how many records. And then here's the output. So it's an intermediate storage location. And here's the storage. It's stored in HDFS. Tells you how many records are written. So that's your log. Then you go back, and then what you might want to do is you might want to look at that file. Now what I did is I just copied stupidly, so that gave me an error. So let me go down a little bit. And so then I redid it because I didn't have the word count, so it failed the first time. So I redid it, and then I assigned a variable of file. From the file system read the output. There are the top words and the count of the words. And then I just did a parse just to show a different way to do it. And then I did the simple graph. So graph.bar of the data inside of here. And you can see the most popular is the, then of, then and, so on and so forth. So maybe that brings a little more clarity around what Mapreduce is. Map is retrieve some subset by key value through some process that is written in Java or C# or JavaScript, and reduce is then apply some aggregation type process through the same methodology. And the power of Hadoop, if you will, is process this in a distributed fashion, massively distributed over many different nodes in many different systems. And there it shows you the output. Now, I guess I'll take a couple minutes and get into Hive. I don't know if I have time for demos, but basically what you can then do is you can create this structure called a Hive table. And again, I detail this in the article. And you can query, you can see if you click on the Hive interface here, that once you've created this table, that you then see it here and you see it as tables and columns. And then you can use some SQL-like statements. So you can see I've done describe, word count table, show tables. So I have two tables here. And I can look and see if I have any tables. don't know if I do. Let me find out. So again, let me go down here. Oops. Got to fix that refresh. I'll put a feedback to Microsoft on that. All right, so here, and I'll go to Hive, and there's the Hive interface. Let's see if I've got any tables. I shouldn't really, because let me go back over here and say show tables and see if I have any. Ah, there. Well, Hive sample table. Okay, I do. Okay, and then select client ID from, and I'm just clicking the button here, Hive sample table and semicolon, and evaluate. And if I have any data in there, it should show up. You got to have the semicolon, case sensitive. Case sensitive in the command line. I'm not actually sure if it's case sensitive in this interface, which of course T-SQL isn't, so that'll throw you off. So this is not going to be thrilling, even if we have data. It's just going to be a single value, but just to kind of show you how it works. And of course, this underscores that Hadoop is not interactive per se, because either A, I don't have data, or B, this is taking a really long time, very different than the relational world. Let me come back to that because it's as exciting as watching paint dry, but you can get the concept basically. So as I said, a lot of what you're going to be doing when working with Hadoop on Azure or Hadoop anywhere is monitoring job results. So you have the main console, you have the interactive console, and you have RDP. So you have a lot of different places to do that. And I actually had shown you how to, this is from the RDP session, the web interface that comes with it. I had shown you how that works. And the next thing is to talk about the interactivity with Excel. Let me go back and see if this actually returned anything. Nope, it's just sitting there. So, all right, so let me launch Excel, and I'll show you what this looks like. So in order to do this, what you would have to do is you'd have to download the Hive Odbc driver, and you would have to create a Hive table. Now the instructions on the FAQ that I showed you in the very beginning to download will tell you how to create the Hive table. Also, I think I put that in the article. Let me actually look while we're waiting around here. And let's see. So this is the actual article, yeah. So yeah, you create and load a Hive table. Okay, so yeah, this shows you how to create the Hive table. It's pretty simple, I guess. You just load it into, overwrite into table. Well, I could actually do that on the one cluster. Let me see. And this one is just not going to do anything for me, so let me close this off. And let me go back here and see if I can get that to go. Let me just go all the way back. And do I do this on the Hive side? Let me take a look. Hive, yeah. So I'm going to go here, and I'm going to go onto the Hive side. And let's see if that will. I'm just not sure if that is in the right location. We'll find out in a minute. See if it works. Anyway, while that's loading, let's take a look over here at working with Excel. Again, this is really kind of interesting. One of the things that I'm really liking about Microsoft's implementation, a couple things. I like the ease of setup, and I like the examples. I also like the fact that they're doing this. So you can see in my screenshot here that I have in Excel, I have under the data pane, data ribbon, I have a Hive data pane. And what I've actually done in this one is I've gone the full thing, and I've connected to Hadoop on Azure. And you can see you have a query writing interface for HQL on the right side, where I've shown the query, the client ID, query time, so on and so forth, and then it's returned back into Excel, which is a really interesting implementation, because as we move to big data, one of the trends that I see is that people who would understand the big data, if you will, are not the database professionals. They are the basically the subject matter experts. For example, I have a manufacturing client that I'm working with, and the people on the manufacturing floor understand the idiosyncrasies of their data, the column 1, 2, 3, rather than time to manufacture, for example, because they've worked with it. So when I'm making more of that data available for them for interactive query, the idea of pulling all the way directly through to Excel is not such a dumb idea. So I'm just curious. So yeah, so okay, so the table, okay, maybe I just need to create the table because it's not there. All right, I'm a glutton for punishment. So load data, overwrite into table. Maybe I just take out the overwrite. Again, I'm not so up on the syntax here, so I'll just try one more time. If it doesn't go, I'll put it on a blog so you guys can see it. So anyway, so in Excel, if I click on data, here's the Hive data pane. And what I would do, and let me make this smaller so I can work with it, is I would enter cluster details here. So I would put the destination where it is, set up the authentication, and then I would work with that. And this has to be a Hive object. So this is, getting into the imposing the Hive table structure onto a subset of your Hadoop data. And then once you have that, then you'll get the list of objects, and it's a click-to-query kind of interface kind of thing. So you get columns, criteria, aggregate grouping, ordering, and limiting. So a subset of SQL, if you will, of what we know as relational SQL. So again, I'm just very curious. Yeah, I have the syntax wrong, so I won't waste our time to worry about that because we're getting to the end here. So also you can connect to Power Pivot. So Danny Lee from the product team wrote a blog on this. You can see I've a link to that. You just create an Odbc connection, and then you can connect to Power Pivot, which is a really interesting use case as well. So real world, why do you care about this stuff? It's beta. Why am I talking about it? Well, Hadoop is sort of the hot button. People are taking a look at it. People are starting to think about it, especially as they consider getting either external data from places like Windows Azure Data Market, or competitor data, or sensor data from people's phones or devices. I know in our family we just got a Nike Fuel Band, so that's new type of personal, health data. I was up in the valley for Google I/O, and I talked to somebody about smart clothing with sensors in it. So the volume of data is exponentially increasing. Interestingly, applications that have this use case already, notably here, most of these are social media sites, tend to run on Hadoop and something. So this is a trend that I see. I call it the junk data, or the sensor data, or the non-transactional data, or behavioral data in many cases, is stored in Hadoop. So some big data bucket and Mapreduce to get some sense out of it. And then whether it's a subset of it is moved, or whether it's just combined with the transactional data, you have a combination of both Hadoop and some other relational or other type of database. So it's usually Hadoop plus is kind of the point that I'm trying to make here. This may actually not be updated because I think that some of these social media sites run on something other than what I've written here, but this was the information as of when I made this slide. So I have a couple of to-dos for you after today, if you've hung with me this far. First, only think about Hadoop when you actually need it. I've had to tell many clients, no, you don't need Hadoop because you only have gigabytes of data. You want to use the right data store for the job. Hadoop on the cloud is a good way to get started, unless you either have the knowledge of running it, because if you run it on Linux, it's a big learning curve. Of course, the Microsoft implementation isn't available, Isotope, yet. You can't run it on Windows. I don't know when Microsoft's going to make that available. So if you run it on the cloud, then the administration is done for you. It's also good to try things out. So like I said, dev, test, or training environments. I've been working with some medical people that are working with medical data, and when you need massive compute for short bursts of time, Hadoop on the cloud is a good solution. You also have to figure out the access technologies. Are you going to learn Mapreduce? Are you going to hire someone? Are you going to use some of the self-service BI tools? How are you going to get meaning out of the data once you get it up there? So there are a number of considerations. Microsoft's implementation is interesting. Another thing that I thought was interesting that I brought to this presentation is I got this from a presentation that I quoted here, MySQL versus NoSQL. And I don't know if I completely believe the data, but if you take a look at it, the way going forward, at least for this presenter, seems to be NoSQL has a lot of growth, and traditional RDBMS has negative growth, which for those of us who are interested in good job security and employability means that we will be adding NoSQL to our skill set, and that includes probably Hadoop for most of us. So the way I see the changing data landscape is RDBMS will have a place. Other services such as data cleansing, processing, data mining are also becoming more and more accessible to more clients. And Hadoop or some other type of cheaper NoSQL data bucket will, for more and more of us, be part of our solutions. So in addition to the work that I do with data, I have another thing that I do professionally, and that is I run a nonprofit called teachingkidsprogramming.org. We provide free and open source courseware to introduce children to programming. Our courseware is based on Microsoft Small Basic or Java, and we are aggressively writing translations to Java for our full Small Basic library. So see our site if you're interested, and teach a kid. We need to work on the next generation. So that brings us to the top of the hour. I appreciate it if you've hung with me. I hope you found value in this presentation. All the materials are available on my blog, lynnlangett.com. You can also follow me at lynnlangett. I'm also actively contracting, working with new and established businesses, helping them understanding their data solutions. So thanks again for listening in, and I welcome any comments or feedback.